Hi there, folks. Today we're looking at standard scores, also known as z-scores. And standard scores are just a way of kind of comparing data in terms of its position once again, but it's measuring the position based on how many standard deviations from the mean we are, okay? And so the standard score, z-score, is the number of standard deviations a value is above or below the mean. And we know if it's above or below if the z-score comes out as positive versus negative, okay? When we get a positive z-score, it means that the data value in question is above the mean by that many standard deviations. And we get a negative value saying, hey, the data value is below the mean by that many standard deviations, okay? And so again, it's just showing us how far away from the mean this is. It's showing us how normal or abnormal this value is, or how much above average or how much below average this thing is, okay? And when you remember, z-scores or standard deviation, standard deviation, when we're within one standard deviation, that represents most of our data values. So if we're at a z-score of like positive 1.5, it means that that score represents something that is well above the average because it's 1.5 standard deviations above average, which if one standard deviation in each direction is most of my data values, 1.5 is quite a bit above, okay? If I had a negative z-score, like a negative 0.75 as my z-score, it just means that that is 0.75 standard deviations below the mean, which is kind of showing us how far below average that value would represent, okay? And so here's how we calculate the z-score or standard score. Remember, x here represents the data value itself. X bar is our mean, our sample mean. And then S is our standard deviation. Okay, and so the z-score, we take the data value minus the mean divided by the standard deviation, and that'll tell us how many standard deviations above or below the mean this data value happens to be. Okay, and so the data we're looking at here, we're looking at a quarterback passing yards from the 1990 season versus the 2020 season. We'll get to a little bit later. But we're looking at these values, and I've already calculated the mean and the standard deviation here. So this way we didn't have to go and punch all the data in and have Google Sheets calculated for us. So there's the mean and the standard deviation already calculated for us. I want to find out the z-score of some of these quarterbacks. So the first one on the list is Dan Marino, a pretty recognizable name in terms of quarterbacks here. But Dan Marino is a fairly famous quarterback. He's considered one of the best of all time. And so Dan Marino here, if I look at his passing yards, I can see him right here. In that season, he was at 3,563 yards. So I'm going to plug him into the z-score formula, where I take his data value, which is his value, the 3,563, minus the mean for the data, and then divided by the standard deviation. And I plug that into my calculator. Just make sure that you do the subtraction before the division. Remember, there's invisible parentheses here. So make sure you subtract and then do the division after the subtraction. And when you do that, you get something like a 0.93, okay? And so that's the z-score here, 0.93. And what that's saying is that Dan Marino is 0.93 standard deviations higher than the mean, okay? And we can see that his score is higher than the mean. The mean was 2,900 something. His is 3,500 something. And so, yes, he's above the mean, but how far above the mean? Well, 0.93 standard deviations above the mean, which means he's pretty well above the mean. Again, when we start approaching that z-score of 1, if we're within one standard deviation, that's most of our data values. So he's on the upper end of most of the data values when we look at a z-score of 0.93. Okay. Next is Vinny Testaverde. Vinny Testaverde is right here at 2818. So to calculate his z-score, I take the data value, which is the 2818, minus the mean, which is still the 2936.24, divided by the standard deviation. And once again, when you plug that into the calculator, just make sure you do the subtraction before you do the division. And we get a negative 0.18. And again, what that's saying is that he is 0.18 standard deviations below the mean. Okay, that's why the value comes out negative, to showing that he's below average. And really at 0.18, he's only slightly below average. So I'd probably consider Vinny Testaverde a fairly average quarterback for this year because he's close to the mean. That's what that 0.18 is saying. And the other thing you have to understand is that a z-score of 0 would represent average. Okay, so when we're talking about z-scores and standard scores, we're talking about a system where 0 is kind of our baseline. All right, so 0 represents something that is perfectly average. Because again, when you think about the formula, it's data value minus the mean. If someone had the exact same value here as they do here, if someone had perfectly scored the exact value of the average, when you subtract, you would get a 0 for the z-score. Okay, so when we talk about this thing in terms of the standard score, 0 represents the average, and then positive values represent how far above the average, negative values is how far below the average. Okay, and so negative 0.18 is pretty close to 0, so we'd say, yeah, Vinny Testaverde is fairly average for this year. Okay, slightly below average, but not by much. Okay. And then the last one here, Phil Simms, there he is, 2284 for his value. So Z equals, that's 2284 minus the mean divided by the standard deviation. And, this is just one measurement of quarterbacks that we're using in terms of passing yards. There are lots of other measurements that tell us how good or bad a quarterback is. So Phil Simms here, he gets a negative 0.97. As a Giants fan, because that's who Phil Simms played for, I had to put that disclaimer out before a really big negative value came out. There are other ways to measure how good a quarterback is, okay? But based on passing yards, he is well below average when we look at this year's numbers, okay? He's almost one full standard deviation below the mean, which means he is on the lower end of the majority of quarterbacks, okay? And just to kind of give us a quick comparison here, like if we look at the percentile ranks of these guys, because when you think about percentile ranks, the percentile rank measures position very similarly to the way that median does it, but the z-score is all based on the mean. Okay, and so just to kind of give us an idea of where these things fall, if we looked at Dan Marino, again, if we counted from Dan Marino on down, if we count all those up, that's 22 data values. And that's out of 25. And so that would be the 88th percentile when we calculate it. Likewise, Vinny Testaverde, if I go back up and count, there's 12 from him on down. So it's 12 out of 24. So that would make him the 48th percentile. And then Phil Simms, if I go and count his, he is 6. 6 that are from there on down out of 25. So that would be the 24th percentile. And remember, calculating percentiles, if you forgot where those values are coming from, I'm just counting and saying, hey, from Phil Simms on down, there's 1, 2, 3, 4, 5, 6. So there's 6 out of the total of 25, and we convert that to a percent. Okay. But again, just kind of thinking about where we were predicting these values and where we're talking about it, Dan Marino's the 88th percentile. And again, when we talk about percentiles, 50th percentile is average, essentially. That's where essentially the median would be. So the 88th percentile, yeah, is fairly well above average. And when you look, yeah, that's what we predicted in terms of the z-score. It's just measuring in a slightly different way. Percentiles measure like the median. Z-scores measure in terms of the mean, okay? Vinny Testaverde was said slightly below average, and look at that, 48th percentile, which is just below that 50th mark, okay? And then Phil Simms, we said, was well below average, and look at that, 24th percentile represents something that is fairly well below average, okay? So now what we're going to do is we're going to do some very similar things, but we're going to use data from the 2020 season. And so in the 2020 season, here's the quarterbacks that we have listed. Here, once again, is the mean and standard deviation that I have calculated for you. And we're going to start with probably the most recognizable name on this list, which is Tom Brady. And Tom Brady, once again, is considered one of the greatest quarterbacks, if not the greatest quarterback of all time. So we'll look at Tom Brady's scores here, and we're going to say, okay, the z-score equals. We take his value, which was the 4633 from the list minus the mean divided by the standard deviation. And once again, this is a job for my calculator. Just make sure you do the subtraction before you do the division. And when I do this one, I get a 1.15 for his Z-score, which again, that means he is well above average. Again, one standard deviation each direction is most of our data values. So he is higher than most of our data values. That is a very high Z-score. And so thinking about it from the perspective of something like outliers, if we get a really, really high Z-score, like a Z-score of 2 or higher than 2, we're pretty much in outlier territory, okay? So Tom Brady's not quite in outlier territory, but he's certainly well into the very high end of this thing, okay? Matthew Stafford. Again, Matthew Stafford is considered a very good quarterback. Let's calculate his Z-score here. So Matthew Stafford, he was at 4,084 minus the mean divided by the standard deviation. And we plug that in and we get 0.39. So we would say, yeah, he's slightly above average, okay? But really, anything that's within one standard deviation until we start to get towards those top ends of that thing, would say is pretty much around average. So yes, Matthew Stafford is slightly above average based on his Z-score because he is 0.39 standard deviations above the mean value, okay? And then once again, since I'm a Giants fan, we'll calculate Daniel Jones, the Giants quarterback who's on this list. 2943 for him, minus the mean, divided by the standard deviation. And once again, I hit the buttons on my calculator and I get a negative 1.20. So it means that Daniel Jones was 1.2 standard deviations below the mean, okay? So when you think about how good Tom Brady was on the top end there, that he was 1.15 standard deviations above the mean, so he's well above average. Daniel Jones on the other end, a little bit further down, so well below average when we look at the number of passing yards here, okay? And again, this is just one measurement that we can measure quarterbacks by. There are other things. But passing yards is obviously important. So we can see that Daniel Jones was well below average. Tom Brady is well above average. Matthew Stafford is a little above average. He's right in that mix. Okay. But then the question becomes, how do we draw comparisons between these two data sets? Okay. When we look at the quarterbacks from 1990 compared to the passing yards from 2020, is it really fair to compare straight passing yards? Okay. When we look at somebody like Dan Marino and Matthew Stafford, if you asked any expert, okay, out there and said, okay, let's compare Matthew Stafford and Dan Marino in terms of greatest quarterbacks of all time, it would probably be a unanimous decision of, well, Dan Marino is a better quarterback in terms of the historical aspects of the game, okay? So we'd say, yeah, Dan Marino's the better quarterback, but he's better with respect to his time. Like if we looked at just their values in terms of passing yards, I'm going to have to scroll back up to Dan Marino. Dan Marino's passing yards here were 3563, okay? So looking at just Dan Marino's passing yards was 3563. And looking at just Matthew Stafford's passing yards, he was at 4,084. And so just directly comparing the passing yards, it would appear that Matthew Stafford is the better quarterback, okay? And again, most experts would disagree with that. And, there's a lot of arguments to be had here. We're comparing 1990 to 2020. That's 30 years difference. And a lot has changed in then. Like, just think about things like sports science, okay? And the different treatments they have for these guys and the different workout regimens and the different equipment that they use, okay, is all better in 2020 than it was in 1990. Okay, the game itself has changed. Some of the rules have changed. How you're allowed to hit each other and hit the quarterback has changed. Okay, and so there's a lot of factors that really change how many passing yards you might have in 2020 versus in 1990. All right. Again, when you look at these, it's not really fair to compare those straight values in terms of passing yards. So that's why we use a standard score. When you look at the standard scores, Dan Marino was at 0.93 for his Z-score. and Matthew Stafford was at 0.39 for a Z-score. So based on those Z-score, we would say that Dan Marino is the better quarterback when it comes to passing yards, okay? And that's probably an accurate assessment. By changing it to a standard score, we standardize these comparisons and make it a little bit more uniform, all right? And so standard scores are a better measurement to compare two different data sets when we know there's things that wouldn't be fair to compare it with straight numbers, okay? So yeah, looking at this, we would say Dan Marino is the better quarterback when we're talking about passing yards. Even though he threw for less yards overall, comparatively, he threw for more yards in his respective year when the game was different, okay? Another way to look at this, and this is one of the things we want to do when we have varying data sets, is I want to know, like, let's say Dan Marino was born 30 years later than he actually was. Okay. So Dan Marino is born 30 years later. So now he plays in the NFL in 2020. He has all the benefits of the new equipment, the new training, all that stuff, and the modified game. Okay. So Dan Marino plays in 2020 as a young buck. And we want to know, well, how many passing yards would he throw for if he had played in 2020? If he was born 30 years later, we're going to make a prediction about that. And really, it's not difficult to do that. We just to say, hey, you know what? We assume that his Z-score would be about the same. So we want to apply his Z-score to the new mean and standard deviation, okay? And so here's the formula that I'm going to give you. This is not an official formula that's in our book or whatever, but this is the formula that makes it easier. Okay, we could set up proportions solve that way. It's just easier to use this formula. So it's the mean plus the z-score times the standard deviation. Okay, and so for Dan Marino, we calculated his z-score at 0.93. And that was using the mean and standard deviation from 1990. If we want to apply that z-score to the mean and standard deviation of 2020 to make a prediction for what he would have thrown for in 2020, so I just used the mean and standard deviation from the 2020 data, okay, which was the 3806, point something, I forgot already, 0.8, plus his z-score times the standard deviation from 2020, which was the 718.1. And the thing is, like, if I plugged his z-score in using the mean and standard deviation from 1990, I'm going to end up with the same number of passing yards that he actually got. If I apply his z-score to his 1990 years, I'm going to get his passing yards, okay, for 1990. If I want to figure out how many passing yards he would have in 2020, I have to apply his z-score to the 2020 values. Okay, so you just have to make sure you're applying the right mean and standard deviation when you're trying to make this conversion. Okay, and so if I plug that into my calculator, I get 4,474.6 yards of passing. And really, that makes sense. You know what I mean? Like, if we believe that Dan Marino is in that upper end of the data around the 0.93 standard deviations above the mean, it means he would fall towards the top like 5 or 6 values. And when you look up here, that value in terms of passing falls right here at number 6, I believe. Okay. And so when we think about Dan Marino's passing yards, if he had been born 30 years later, that's where we believe he would fall in the conversation, okay? And so when we take that into consideration, we can see he's well above where Matthew Stafford would be in terms of the comparison if they had played in the same year, okay? So again, standard scores, it's the data value minus the mean divided by the standard deviation. And we use standard scores because they are a better comparison when we're looking at two different data sets, okay? To further illustrate that, we can always convert using a standard score. We can take their standard score, apply it to the other data set using the mean and standard deviation to kind of make predictions about where they would fall had they been included in the other data set. Okay.